Hi, and welcome to TEMEKO. In this video, we'll learn the definition of rectilinear motion and which different aspects characterize the kinematics of a particle. We will also get familiar with some of the basic equations for cases in which the particle is experiencing constant acceleration. Let's get started. So what is meant by rectilinear motion of a particle? We can say that a particle is in rectilinear motion when the motion of the particle occurs along a straight line. Note that we can think of some objects to be particles if they have a finite size. These objects can be, for instance, vehicles, projectiles, and rockets. But while doing this simplification, we must keep in mind that we should only consider the motion of the body's mass center and neglect any rotation of the body. Let's now dive into the characteristics of kinematics of a particle. Let's start with the position of the particle. What is it precisely and how can it be defined? To define the position of a particle, we can use one coordinate axis called S. The position P of the particle can then be defined by using the position vector R, which is parallel to the axis S. How about the displacement then? How does it differ from the position? Well, we can define the displacement of a particle as being a change in its position. Think about this. If the particle moves from point P to P', then the displacement of the particle is delta R equals R' minus R. We can also represent this displacement in scalar form like this. Delta S equals S' minus S. Let's move now to discuss about the velocity and acceleration of a particle. We can represent the average velocity of the particle which moves by the displacement delta R from point P to P' in the time delta t in a mathematical expression as follows. V average equals delta R by delta t. We can also represent the instantaneous velocity of the particle as follows. V equals to dr by dt. On the other hand, we could also represent this in scalar form as follows. V equals ds by dt. Likewise, if we know the velocity of the particle in points P and P', we can represent the average acceleration of the particle in mathematical expression during the time interval as follows. A average equals delta V by delta t. We could also solve the instantaneous acceleration of a particle from the following scalar equation. A equals dv by dt equals d2s by dt2. Note that the particle could experience acceleration even if its velocity would be 0 meters per second. One very typical case related to this is when the particle is decelerating. In this case, the end velocity of the particle would be 0 meter per second. When it has stopped, while at the same time, it experiences negative acceleration, which is also referred to as deceleration. As a last topic, let's go briefly through the collection of basic equations in a case where the particle experiences constant acceleration. Firstly, if we integrate AC equals dv by dt, and assuming that initially v equals to v0 when t equals 0, then we obtain the following equation for the velocity of a particle as shown here. Integration from v0 to v of dv equals integration from 0 to t of ac times dt, which gives v equals v0 plus ac times t. Likewise, if we integrate v equals ds by dt equals v0 plus ac times t, and assuming that initially s equals s0 when t equals 0, then we obtain the following equation for the position of a particle as is shown here. Integration from s0 to s of ds equals integration from 0 to t of v0 plus ac times t times dt, which gives s equals s0 plus v0 times t plus half of ac times t squared. So finally, if we integrate v times dv equals ac times ds, and assuming that initially v equals v0 and s equals s0, we obtain an equation for the velocity as a function of position as is shown here. Integration from v0 to v of v times dv equals integration from s0 to s of ac times ds, which gives v squared equals v0 squared plus 2 times ac times s minus s0. For your convenience, while doing calculations, you can directly use the derived equations and not bother with the integrals. Thus, the needed calculations get a bit easier for you. Hopefully, after watching this video, you know the definition of the rectilinear motion of a particle, and you are familiar with the aspects that characterize this kind of motion. You also know what kind of equations can be applied when the particle experiences constant acceleration. Thanks for watching and have a nice day.